Hi, I'm Karen Bemis from Rutgers University in the United States. My poster looks at the distribution of volcanic cones in the Central American arc and tries to understand what can be inferred about long-term magma supply. This study maps as complete a set of volcanic cones as available by both volcano type and timing of activity. The Central American arc has been active since at least the early Neotene. In his 2017 database, Mike Carr divided cones into currently active, recently active, and visibly older cones, as well as a group of possible cones that could not be confidently identified as volcanoes. Active and recent cones are further identified by volcano type. Although only cone heights are available for most of the arc, full morphologic data is available for the northwestern part, noting that the ratio of cone height to basal radius is similar across the most relevant cone types. I estimate volume by assuming the basal radius is 4 times the cone height, which produces estimated volumes that are highly correlated with the actual volumes. The largest errors are for Mars and calderas. With estimated volumes for most of the arc, we can start looking at distributions. To facilitate plotting a long arc, all locations were converted to an along arc and a cross arc distance. These plots show the number of cones of each type in a 25-kilometer along arc distance, the volume that represents, how the cone counts and volumes split across age groups, and how spatial densities vary. This clearly demonstrates that a few large composite cones dominate the volumetric accumulation. Also, the active period may have greater volumetric output. In seeking to understand controlling factors, I turned to Castruccio's model of shield volcano growth, which implies a specific relationship between magma chamber volume, cone height, and basal radius. Models of constant magma chamber volume, as well as contours of cone volume, overlay the plot. The boundary between complex and monogenetic types corresponds to the line of equivalence between cone and magma chamber volumes. Thus, creating large cones requires focused volcanism with multiple eruptions using the same plumbing. In conclusion, the balance between distributed and focused volcanism varies along the Central American arc, controlling where larger cones grow. Total volumetric output seems higher in the northwestern part of the arc, but that depends on only a few cones dominating the output. The monogenetic systems of the more distributed volcanism, the Guatemala-El Salvador border, and in southeastern Nicaragua, may suggest areas where magma batches often stall in the crust. Thank you for listening.